Welcome to Martin's Institute of Teaching. Today we are going to be working with, or we're going to do how to solve for frequency and wavelength. We did this in a previous video, and now I'm just going to be doing a few more problems that I think would help you out a bit. These actually were kind of worked out by somebody else, but apparently some of them were incorrect and they had questions on them, so I'm just going to go over them to show you the correct way to work them out, or at least with the correct answers. Okay, so let's go over the very first one. So find the frequency if lambda is equal to 5.9 times 10 to the negative meters. Now, for solving for all these problems, all you really need is this formula right here, which is the speed of light is equal to the wavelength, lambda. Well, lambda represents the wavelength, times the frequency. So here we're asked to solve for the frequency, which means we just manipulate the formula to look like this, which is the frequency is equal to the speed of light divided by the wavelength. So let's go ahead and do that. So here, the frequency will be equal to the speed of light divided by lambda. Now here we're given lambda, so this is just a straight plug and chug problem. This is going to be 3 times 10 to the 8 meters per second. And this is going to be all over 5.9 times 10 to the negative 7 meters. So immediately we can see that meters is going to cancel out, and so the units are just going to be 1 over seconds. Okay, 1 over seconds is the same thing as hertz, so that's equivalent. That's just what the units are for hertz. So now let's go ahead and work out this problem. Well, for this one you're just going to throw it into your calculator. That's what I'm doing right now. So if you want to put this into your calculator, you actually use if you're using like a TI 84 or a TI something or other, you use the EE command. So you would actually press 3 EE and 8, and that'll give you this right here, 3 times 10 to the 8. To get the EE function, you just press the second button, and if you're using the TI 84, it would be right above the comma. So if you look at your calculator on the keypad, you'll look at the numbers. That's probably the easiest way to find it. Look at the number 7. So one key above that, you'll see the comma one, and right above the comma, you'll see the subscript EE. It's going to look like this. You're going to have your key like this. This is going to be comma, and then right here you're going to see EE, and this is the one you want, and you just get that by pressing second, and then you just press the comma button, and it'll give you EE, which is the same thing as saying times 10 to some number. That some number is going to be what you press after the EE. Okay, so I hope that made sense. If it didn't, I'll probably have to make a video on that too. So anyhow, and if that really makes no sense, what you could do anyways is just, when you see times 10 to the 8, really what that means is 3 and 8 zeros behind it. So you can type it in your calculator that way. So okay, so I'm going to go ahead and give you the answer to this. So that's going to be 3 times 10 to the 8 divided by 5.9 times 10 to the negative 7. So that answer is going to be, it's going to be a frequency which is equal to 508 point roughly 5. So I'm just going to, this is approximately 508.5 times 10 to the 12. You'll also see it written a little bit differently. You can also see it as 5.08 times 10 to the 14. So either one's the same, and the units are hertz. Okay, let's go down to the next problem. Now you have here, and it's asking you to find the frequency if lambda, the wavelength, is equal to 550 nanometers. Well, this is exactly the same as the first problem. It's just the frequency is going to be equal to the speed of light divided by lambda. And again, we're just going to pop in 3 times 10 to the 8 meters per second over lambda, which is 550 nanometers. Nanometers, by the way, is the same thing as saying, so if I have, let's say, 3 nanometers, it's the same thing as saying 3 times 10 to the negative 9 meters. Because nano means, well, it means it's a really tiny number, so it's like if you have a point and then a bunch of zeros way over here. Okay, So that is nanometers. So for this one, you're just going to type in, if you were to do this like this, you'd say 3 times 10 to the 8, which is 3 times 10 to the 8 divided by, you could say 550 times 10 to the negative 9. So what is that? 550 e to the negative 9, and you should get a value of a frequency which is going to be equal to 545.5. This is rounding. So 545.5 e to the 12, or I mean, and really this is just how many decimal places you're going to have to shift this. You could also see it as 5.45 times 10 to the 14, and this is going to be, of course, in hertz, because here these meters cancel out with those meters, and that's because I shifted it here to negative 10 to the negative 9, which is what nanometers is. Okay, so now let's go on to the next one, number 3. So here it says find lambda if the frequency is 4.98 times 10 to the 14 hertz. So of course we know that the formula c, which is the speed of light, is equal to the lambda, the wavelength, times the frequency. And since we're solving for lambda, well, we're just going to manipulate this formula to say lambda is equal to the speed of light divided by the frequency. And so we just do the same thing we did to the previous one. This again is 3 times 10 to the 8 meters per second, all over 4.98 times 10 to the 14. And this is hertz, which hertz again is the same thing as saying 1 over seconds. 1 over seconds. And if you have units like this, meters per second, over 1 over s, what you could rewrite that as is saying meters over second times, and when you get something down here like this, you just flip it. So this would be s over 1. And now the seconds cancel and you're just left with meters. Okay? So now this is going to be 3 times 10 to the 8 over 4.98 times 10 to the 14, and it's going to be meters. Okay, so let's go ahead and get that answer. It's 3 e to the 8 divided by 4.98 times 10 to the 14, and that should be equal to, this is going to be in nanometers. You could say that this is about, so the wavelength is about 602 nanometers, or you could say this is 602 times 10 to the negative 9 meters. Okay, so these are the exact same answer. Here I just converted it to nano. Here, since I mean, you can just see it, since it's 10 to the negative 9, you know this is in nanometers. Okay, so let's go on to the last and final problem. So here we have lambda. So find lambda if frequency is equal to 5.4 times 10 to the 14 hertz. So again, we know that lambda is equal to the speed of light divided by frequency. You're going to pop in the speed of light, which is 3 times 10 to the 8 meters per second, all over 5.4 times 10 to the 14 hertz. We already know that hertz is 1 over seconds. We know that meters over seconds divided by 1 over seconds is the same thing as just meters, because we worked that on the previous one. So here we have 3 times 10 to the 8 divided by 5.4 times 10 to the 14 in meters. Let's go ahead and give you that answer. 3 e to the 8 divided by 5.4 e to the 14. That is the same thing as 555.5 infinite fives times 10 to the negative 9. Or you could call this, you could say that the wavelength is equal to 555.5 continuous forever nanometers. So either one of these two answers is equivalent. So, okay, hope that helped you out. Hope you enjoyed it. Good luck in your classes, and don't forget to click like if you liked it, and subscribe. So, see you later.